Okay, we're back. So after figuring out the blood typing information or blood typing probabilities, we're ready to go with taking a swing at this second example. We're going to toss that loaded coin that we spent some time talking about in class. It's got a 75% chance of coming up heads. So of course, if it's got a 75% chance of coming up heads, the probability of tails is equal to 0.25. Okay, so 75% of the time it's heads, and the probability of tails is 25%. So I'm going to fill that in just so we can keep that in mind. So what is it asking us for here? It's saying assuming that each coin toss, these coin tosses are independent of each other, what's the probability of at least one head? So at least one is code for complement rule. So we want the probability of at least one head. That means we take 1 minus the probability of 0, or 0 with an X, 0 heads. Okay. What does that look like? Well, on the next page, apparently, because I run out of space. Let me scoot it up here. What that looks like is 1 minus. We're flipping the coin twice, and so if I get 0 heads the first time, that must have been a tail. And if I get 0 heads the second time, that also was a tail. So 1 minus 0.25 times 0.25 equals, in this case, 1 minus that, which turns out to be 1 minus 0.0625. The end result is 0.9375. So if you were to bet somebody that, hey, I've got this coin, I bet you I'll get heads on at least one of the two tosses, you're going to be right almost 94% of the time. Pretty good odds. So, continuing on, the next page says we've got a whole bunch of possibilities here, all dealing with that standard poker deck. 52 cards, and we're going to give 3 decimal places when necessary as possible here. So each one of these is dealing with an at least situation. But it's important to note that each one of them tells you how many cards are going to be drawn at random, and they all have with replacement and shuffling after each draw. Why is the with replacement and shuffling important? Think about that for a second. And of course, if I'm telling you it's 2 cards, then I need to know that when I draw the first one, write down the answer or write down what I get, put it back, and try it again. I have to, in each case, guarantee that these things are independent. Each event is independent. And that's what the with replacement part means. So if I want to be able to talk about the probability of at least one ace, there's the language that I want to use. And at least one ace means complement rule. That means I'm going to find the probability of at least one ace is equal to 1 minus the probability of no aces in 2 draws. So the reason I have to have replacement is so that I can guarantee they're independent. So in this case, probability of at least one ace is 1 minus the probability, 1 minus the probability of no aces, which corresponds to, for the first card, 48 out of 52, because it can't be an ace, times 48 out of 52, because it can't be an ace. And when I do the calculations for that, I wind up with 1 minus 0.852, roughly, which turns out to be 0.148. So it's about a 15% chance that I'm going to have at least one ace in a 2 draw. So the rest of these follow the exact same pattern. Okay, so for this one, I'm looking at least one diamond out of 2 cards. The next one after that, 3 cards drawn, and at least one ace. And the next one after that, at least one diamond. And all of these, you can see,